Hello, how are you? We have question 29. The question says, study the opposite circuit and answer the following questions. I have R1 is 4 ohm, I'll write there. R2 is 6, so I'll write it down here, okay? And R3 is 2 ohm, so it is here too. I'll put the unit ohm, okay? Okay. In A, they want me to find I1, I2, and I3. Okay? In here, as you can see, I have three variables. I need to calculate three things, I1, I2, and I3. Which means that I need to write three equations and solve them simultaneously. Okay? So the first equation, we can write it depending on or using Kirchhoff's first law on the junction C. Look here, it is on junction C. I will apply Kirchhoff's first law. So the sum of currents entering, which are, I have I1 is entering C and I2 is also entering C, equal the sum of currents leaving. Which one is leaving? It's only I3. Okay? So this is the first equation we are going to use. Okay? Now, to get the second equation, we apply Kirchhoff's second law on the upper junction. As you can see in the upper junction, they gave me this direction here, which is clockwise, okay? I have a clockwise direction in the upper loop. So I will write upper loop, okay, clockwise. When they give me the direction here, guys, you are not allowed to change it, okay? You have to follow it. So I start with the batteries. I know that it is I1, I2 minus IR minus IR. So I start with the batteries with the electromotive forces. Pay attention here about the 20 volt. You see this direction, the direction of the motion, it goes out of the negative, right? So I get minus 20. Okay, regarding the other battery, which is here 28, in this battery, the direction will go also there, right? It will go like this, clockwise. So it's also minus, so we write negative 28. Okay, this is regarding the batteries. Now, regarding the resistors, we know it's minus IR. Here, in the R1, what current goes into R1? It's actually I2, because notice on in all this part here, all of it, I have I2 in here, okay? So, I2 agrees with the direction of motion, which means I will get minus. When it agrees, it says minus. Minus IR, which is 4I2. Okay? Regarding the R2, which current goes into it? It's I1. So, I1 doesn't agree with my direction or with the direction of motion, which is clockwise. That's why it's going to be plus 6I1 equals to 0. Okay, let's fix this equation. I will have minus 20 minus 28 equals minus 48 minus 4I2 plus 6I1, okay, equals to 0. So this is the second equation that we are going to use. Okay, I hope it's clear. Now, regarding the third equation, we apply Kirchhoff's second law on the lower loop. Okay, notice also they gave me the direction here, which is also clockwise. I will write lower loop, also clockwise. I have to follow what they gave me. Okay? I have only one battery. The direction of motion clockwise, it goes out of the positive of the battery, so it's going to be 20. Regarding the resistors, I have R2, R3 with the currents I1 and I3. So I1 goes into R2 and it agrees with the direction, so it's going to be minus 6I1. And the current I3 goes into R3 and it agrees with the direction, so it's going to be minus R3 I3, which is minus 2 I3 equals to 0. And this is the third equation. Okay, guys? Now, I have these three equations. I need to solve them together to find the I1, I2, and I3. Notice that I1 is in all of them. That's why from the equation 2, from this equation, I'm going to find I2 in terms of I1. So from 2, okay, I can write 4I2. Okay, feel free to pause the video if you feel like you need to understand how we adjust this formula. It's going to be here minus 48 plus 6 I1. We just took the I2 to the other side. Okay, so in order to get I2, we'll divide by 4, so it's going to be minus 12 plus 1.2 I1. Okay, this is I2 in terms of I1. I'll name this 4. Okay, now from equation 3, I need to find I3 in terms of I1. Okay, from equation 3 we find that 2I3, I just took the 2I3 to the other side, equals 20 minus 6I1. To get I3, I divide both sides on 2, so I will have 10 minus 3I1. This is the I3 in terms of I1, and this is equation 5. Okay? Now, I substitute equations 4 and 5 in equation 1. So, instead of here, I1 stays the same, I1. Okay? Instead of I2, what can I write? I can put this one. Instead of I2, I put minus 12 plus 1.2 I1. Okay, and instead of I3, I go to equation 5 from this one. Okay, I can say I3 is 10 minus 3 I1. Now, I put the variables in one side and the numbers in one side. Okay, so I bring the 3 I1 to the first side and I take the 12 to the other side. So it's going to be I1 plus 1.2 I1 plus 3 I1 equals 10 plus 12. So I will have 5.2 I1, I added the first side, equals 22. Okay, from here I can find that I1 equals 22 over 5.2, which equals to 4.23 ampere. I got I1 positive, so no need to change its direction. Okay, I1 stays entering the junction C. It stays entering the junction C. Okay. Okay. Now I use the value of I1 and I substitute it in equation 4. in order to find I2. So I'll come right here. I2 equals minus 12 plus 1.2 multiple 4.23. Okay, you can use a calculator. You will get I2 is like 6.9 something, so it's almost 7, and it's actually negative. Since I got it negative, this means that I have to change the direction of I2. I go up here. Let me erase some things here just to understand what I'm talking about. Now we are talking about I2. We found it minus 7, which means this direction have to be changed. So it's not entering that junction C, it is leaving junction C. So this one will become positive. Okay, so we change the direction in order to get it positive. Okay, I write I2 leaves, okay, C, the junction C, and I2 I write it, sorry, not negative, it is positive. It is positive 7 ampere. Okay, here's going to be ampere. So this is I2. Now, since I have I1 and I2, I can go to equation 1 and find I3, right? I can find I3 simply. Okay? So, I have yes, I have I1 plus I2 equals I3. Pay attention, since I2 we have it in the equation 1, we have it in the I in, it means I have to keep the negative value for I2. Okay, so it's going to be 4.23 minus 7 equal I3. You ask me, Mr., why you put negative? Because when I2 was entering the C, we got it negative. So here we use it negative. 4.23 minus 7, I will get minus 2.77. Okay? So I3 equals minus 2.77. Okay, since I got it negative, guys, I have to also change the direction of I3, right? So it's going to be here. Here I3, since I got it negative 2.77, it means this direction here should be changed. So I3 will enter, and this one will be positive here. It's going to be positive. Okay, so I go down and I write what I just said, which means I3 enters junction C. Okay, and I3 will be 2.77 ampere. Okay, some students may ask me, Mr., like, now how about I2? Are we going to take it negative or positive? No, the current always positive. Okay, so why did I use I2 in here? Why did I use it negative? Again, I insist on this idea because I made it positive when I say it leaves the junction C, but in equation 1 we used it as entering. That's why I keep the negative value in here. Okay, by the way, you can find I3 also by applying Kirchhoff's not Kirchhoff, sorry, you can substitute I1 in here in the equation 5. Okay, and you will get the same answer. Okay, please do it and tell me in the comments what you got. Now, Calculate the power delivered to capacitor or to resistor 4 ohm. To the 4 ohm. Which one is the 4 ohm? It is the R1. Okay, the R1. We agreed that R1, what current goes into it here, which is I2, right? Which we got it 7. The current here is 7 ampere. Okay, so I have the R is 4 and the current is 7. Okay, so the R is 4 ohm and the current goes into it, which we found it I2, it's 7 ampere. So the power is R I squared, which is 4 multiple 7 squared. Okay, the power will be, I use my calculator, 4 multiple 7 squared equals 196 watt. Okay, I hope it's clear. If you have any question, guys, please leave it under the video. Again, I encourage you to find I3 by substituting I1 in here in the equation 5. Okay, have a nice day. Bye bye.